Now, depending on how you look at it, this is either part 3 of the Intro to Arduino heading towards an elevator, or it is a standalone video that is going to be a walkthrough of my elevator project as a demonstration. In the interest of time, I have decided not to build this program from scratch, step by step, the way the first 2 videos were done, because they were quite long. And instead, we are just going to do a walkthrough of my final program, which was based on what you've already seen, to explain what has been done and how it works. Now, I decided to go in a little bit of a different direction in the last couple of weeks and expand this significantly into an actual physical project with some cool things. But this video is just the culmination of the essential assignment requirements for G2 Lab 5. So here's what we have. In the program, we have comments. Now, as a quick note, if you are doing comments for a single line of comment, you can use the double slash. But if you're making a comment or need to comment out a large chunk of code all at once, you can put a /* at the beginning of it and a */ at the end of it and take care of the whole thing. Our basic elevator sketch has 4 push buttons and 4 LEDs. I'm using the defines to hold the pin numbers, which makes it very easy to update the pin numbers if the pins change. If I do damage to a pin, I can just change this single number and reference that pin through the program with this label. We are defining the top floor as floor number 4. This has been expanded as well and can change. The lobby is floor 1, the lowest floor we have access to. We want our elevator to currently be constrained between floor 1 and floor 4 exclusively. The initial position in the elevator doesn't really matter too much, but it's good to initialize it. I have initialized it to floor 0, which you can think of as a basement position or a maintenance position. In order to keep track of what floors are being serviced, I have created a Boolean array, which is essentially the same as having bool PB state 1, bool PB state 2, bool PB state 3, etc., etc., etc. But you can make an array of booleans, which can be accessed by simply sticking a number in between the square brackets, other places in your code. So for the moment, I am initializing an array of booleans called PB state, and I'm initializing PB state 0 to false, PB state 1 to false, PB state 2 to false, PB state 3 and 4, which is currently our top floor. But please note that you do need 5, because if we're going to reference floor 1 as floor 1, we need to take into account the fact that there is an array position 0. We can ignore 0 in the rest of the code, but we can't ignore 0 when we're initializing it. Later on, I'm going to scale this up a little bit to add additional floors. But for the moment, this is the basic requirement. In the original program, we were checking for the input digital read floor 4 push button, which was doing a digital read of pin floor 4 PB, which was defined as pin 12. This is the same as saying digital read 12. Because these push buttons have an inverted state, when they are not pressed, they are ones or trues. When they are pressed, they are zeros. And we want in our program to have the fact that it's pressed reflected as a 1 in the state. We're using the NOT operator. So if digital read pin floor 4 PB returns a 0, what is actually returned to the code when we use the exclamation mark ahead of it is the opposite, the NOT. So not 0 is 1, not 1 is 0. Not false is true, not true is false. In the original program, we were simply reading the push button. Now, we are going to look at the current state of the push button and do an OR operation with the state of the physical input. So let's say we initialize 0, 1, 2, 3. Let's say we initialize floor 3's push button as false, meaning that the floor 3 push button has not yet been pressed. When we get down into the loop where we check floor 3 push button, we are now doing a few extra things. PB state 3 is initially false, but PB state 3 is going to be updated with the logical operation current state of PB3, which is false, or the state of the physical input. So if it's initially false, then it's going to be false or false, because the push button is not pressed. And so the state after this line executes is going to be PB state 3 being equal to false. And the push button is still not pressed. On the other hand, if the push button is not pressed, so it's false, and we get to this line, we're going to update the status of the push button for 3 with the fact that it was false, or now it's true because the push button is pressed. The OR operator of false or true is going to result in a true, and that is going to update PB state 3 in the array to true, indicating that the call button on floor 3 has been pressed. If the call button was already pressed and some impatient person presses it again, it doesn't matter, because true or true is still true. It's not going to make the elevator come faster, just like in real life. A new command from the first two videos is the for loop. The for loop allows you to initialize a value, check PB often, in this case an integer, to be a value. It doesn't have to be 0, but I'm starting off with 0. So we are initializing a variable that is an integer called checkPBOften to be equal to 0. As long as checkPBOften is less than 10, meaning that it's 0 through 9, this code will execute. And after this code executes, checkPBOften will be incremented by 1. The code executes where we check the state of the 4 push buttons. I'm doing a small delay 10 times, which is going to equal 1.5 seconds of checking the push button status every 150 milliseconds. That's in order to catch push buttons when they're pressed. I don't want to wait 1.5 seconds potentially before pushing a push button is actually captured by the program. So I am using this simple logic versus using a timer interrupt, which you can look up and learn more on your own, or I may cover later, to check the push buttons 10 times for every 1 time the rest of the code executes. After updating the status of the push buttons, we want to figure out what direction we're going. So initially, I have a few new variables. I want to check for more floors above our current position. Initially, when coming into this section of the program, we're going to set more floors above our current position equal to false. And it is only going to become true if there are more positions, if there are more floors calling for the elevator above the current position. So now, in this piece of code, with the for loop, we're going to iterate through the value of I, which is an integer, but its initial value is not going to be 0. It's going to be the position of the elevator, which could be floor 1, floor 2, floor 3, floor 4. Let's say the elevator is at floor 2. I is going to be initialized to 3, because if we're at floor 2, we don't care if the floor 2 push button is pressed. We only care if floor 3 or 4 is pressed. As long as I is less than or equal to the top floor, less than or equal to 4, we will execute this code. This code checks the current status of the push button, the array, and it specifically checks the current status of the push button referenced by I to see if it's true, to see if it's pressed. If we have pushed push button 3, then PB state 3 will be true. If it is true, more floors above is equal to true, changing the state of our initial false. Now, we could actually break out of this loop right now because we've found a floor above our current position. And all we really need to know is, do we need to continue going up? But I'm not going to do that extra step because it doesn't take a lot of time to iterate through floor 3 and then floor 4 to verify whether floor 3 or floor 4 is called and indicate that yes, one of the potentially many floors above floor 2, which is where the elevator currently is actually requesting service. We also need to check for floors below our current position. The code is the same, except for after being initialized to one less than the current position, and continuing through the loop as long as we are above the lobby or equal to the lobby, so we do actually want to check push button 1 as well, then we decrement the current position that we're checking. So if we were at position 3, then it would be initialized to 2. It would check position 2 to verify whether or not the push button had been pressed, and if the push button has been pressed, then yes, there are more floors below our current position that need servicing. We do not want to reverse the elevator's direction of travel until all floors above, if we're moving up, have been serviced, or all floors below, if we're moving down, have been serviced. The elevator status, which I skipped by a little bit up here, the elevator status, the elevator general status, is going to be an integer elevator status initialized to 0, meaning that the elevator is idle and not called to any floor. If it's called to a floor above its current position, then it's going to start moving up. If it's called to a floor below its current position, then it's going to be -1 and moving down. We will only allow the status to change to up or down if the elevator is idle. And the elevator becomes idle once we've serviced all floors. in that direction. So, if the elevator status is moving up and there are no more floors above us, set the elevator status to idle. On the other hand, if the elevator is in the process of moving down the shaft and there are no more floors below, then again, we will set the elevator status to idle. Once the elevator status is idle, we can check for calls above or below and service them. So if the elevator status is idle and more floors above is true, then we'll start moving up. Otherwise, if the elevator status is idle and there are more floors called below, we'll start moving down. And the other possible option, the catch-all for everything else. Now, realistically, I probably would not instantly send the elevator to the floor, to the lobby, just because it was idle. I would probably insert a small delay of a few seconds or a few minutes. But it's not critical for this. So for the moment, we're very simply sending it to lobby anytime no other floor is calling it. Once we've checked positions and checked status and decided whether the elevator is moving up or down, we can move the elevator position up or down. If the elevator service is moving up, then increase the elevator position by 1. But we're not allowing it to go any higher than top floor. If the elevator status is moving down, then the position will decrease by 1. But we don't allow it to go below lobby. Here we print the status of the elevator. So this is the real-time position, the floor that it's at. This is a status bit. More floors above, yes or no. More floors below, yes or no. And the elevator status is printed out as well. Is it moving up? Is it idle? Is it moving down? A little label for the following bits, and then we'll print out the status of the push buttons being pressed or not. This code is only useful if we only have 4 floors. If we have more than 4 floors, then I will enable this code instead, which iterates between lobby and whatever our top floor is, however high our building is, and prints the status of all of the array bits, separated by commas. Finally, do a carriage return. This original code is simply checking for, is the position of the elevator at 4, turn on the elevator light, print to the serial console the fact that we're at floor 4. I decided to wait at each floor by half a second, but this can certainly be changed. You don't want it to be too large. Otherwise, with the current code as it is, you will miss push button presses that are faster than half a second. And finally, since we've serviced floor 4, we now want to set its call status to false. If it's not at position 4, turn off the light. Repeat for floor 3, floor 2, and our lobby. This code is consoled out again because I've expanded this so that it can do more than just 4 floors. I'll enable that in a minute. And initially the delay was 1.5 seconds between floor moves, but now that 1.5 second delay is being taken care of by checking the push button status 10 times every 150 milliseconds before actually doing anything with the elevator. And finally, for a little bit of fun, since it's a little difficult to test this well, in the simulator. It's a little difficult to push the push buttons in reasonable amounts of time to actually watch and diagnose how things operate. I have this little code which randomly selects a number between 0 and 9, and if that number is less than 3, so 3/10 of the iterations on average through this program, it will randomly select one floor and activate the call button. So to do our initial demo, I'm going to disable the automatic return to lobby. Start the simulation. We begin at floor 0 with no calls above, no calls below. The elevator status is idle, and the individual push button call states are false, 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 false. If I tell it to go to lobby by pressing the floor 1 push button and stop the simulation briefly, you'll see in the feedback. Now the order of the code is a little bit odd, and because everything happens so quickly in the code and jumps fully to the next floor when called to that floor, the status update is a little interesting. So I push the push button, and you'll see that on the next update, the floor 1 push button was pressed. So we were called to floor 1. On the check, yes, there was a floor above our current position of 0 that wanted service. And by the time we were printing, it had already moved to floor 1. So the current position was floor 1. And it was now at lobby. And once it was at lobby, and it went through that push button check again, it saw that there were no push buttons pressed. The elevator status is now idle because there were no calls above or below floor 1, which is where we were. And at that point, the elevator is just waiting for the next service call. If we restart the simulation, we're at floor 0. So what happens if we call the elevator to floor 4, and then floor 1, and then immediately back to floor 4 as it's moving down? Floor 4, it begins moving up. I call floor 1. It's active, but it doesn't immediately reverse. It gets to floor 4. I call floor 4 again. It goes all the way down to the lobby before coming back up to 4. Floor 2, floor 4. You missed that push button. Floor 2, floor 4. Three, 2, 1, 3, 4. The simulation is missing some of my push buttons. So let's enable the random floor push. Initially it's idle at 0. Eventually we'll get a floor push to the lobby. It went to lobby. Then it gets a call to floor 2 and goes to 2. Floor 3 goes to 3. Floor 1 shifts down to 1. Floor 2 went to 2. Now with only 4 floors and only randomly assigning push buttons and randomly calling it to floors every 3 out of 10 iterations, we're not going to get a lot of overlap. But let's assign a random push on every iteration, or maybe 3/4 of every iteration. Now, let's stop the simulation. With only 4 floors, it's a little difficult to see how this works. But if we had more floors, so let's go back to every 3rd iteration again. Or, sorry, about 30% of iterations will get a random floor button press. And let's increase the maximum floors to 20 floors. Now, in order to get 20 floors, we need a larger array. And rather than initializing this array with 21 falses, we can do this more automatically. So now we have an array that has 21 elements, 0 through 20. 0 is mostly being ignored, but floors 1 through 20 are active. We're only going to get lights on floors 1 through 4, but the elevator is capable of being called to the other floors. And I missed a modification. So now, also, PB states cannot be hard-coded as just 4 states. So, /* to comment out the individual prints. And now we're going to enable this code, which prints out the statuses of all buttons from lobby to the top floor. And at each floor, we can't just turn off the status, the push button status for the individual floors 1 through 4 that have push buttons and lights. We also have to check and clear the push button state for whatever the current position of the elevator is. So now if we begin this simulation, initially there are no calls and the elevator is idle. We get a call to one of the upper floors and it begins rising to an upper floor. It gets additional calls below that floor while it's moving up, but it continues moving up. Eventually it got to floor 13, cleared 13, and is now on the way down, servicing floors all the way down to floor 3 before reversing and going back to whatever floor this is, an upper floor that was called on the way down. And we can still select specific floors. So if I want to go to lobby, I can press lobby. And that calls me to lobby. When I reach lobby, the status is cleared and the elevator is allowed to move up to 7th floor and whatever these floors are before coming back down to floor 3, which I just activated. The final part of this in your assignment was that if no floors are called and the elevator is not at the lobby, send it to the lobby. I'm going to activate fewer random push buttons. So if random is less than 1, which means 1/10 of the iterations will result in a random push, then it'll set a random floor called. But up here, if position is not at lobby when the elevator is idle, call it to the lobby. That includes the initial startup at floor 0. If I call it to floor 3, it'll go up to floor 3 and then reverse back to lobby. However, there was an automatic call to an upper floor before it got to floor 3, so it's going to go up to that floor, service it, clear the bit, and the random calls are interfering with testing that code, so I'm just going to turn off the random floor selection for this last test. So we start at floor 0, it's not at lobby, so it gets called to lobby, everything is idle. Call to floor 4, it will go up to floor 4. Clear floor 4 and go back to lobby. 4, always returning to lobby. Now the nice thing about this simulator and this simple program is that this code that we've written in TinkerCAD is directly copy and pastable into the standard Arduino software. And with no modifications, we'll work on the hardware. Verify the code. It asks us to save it. It checks for errors. If there are no errors, it'll simply tell you how much of the Arduino's memory it takes up. This does change based on what board you're using. So in the simulation, we were using an Uno. If we select, instead of the Uno, the Mega, which I have sitting on my desk right now, and redo the check, rather than taking up 10% of the total memory space, it's going to be a lot less. Because among other things, the Arduino Mega not only has more memory, but more I/O and more serial ports and various benefits. But the nice thing about the Arduino ecosystem is, generally speaking, if you write a program on one, you can run it on any other board, from the tiniest to the biggest, if it'll fit in memory. So, step 1 is select your board. Step 2 is, once your board is selected, plug in the board, to USB, and under port, select the port that your Arduino is connected to. We already verified it for errors, so now let's send it to the Arduino. Done uploading. And if we open the serial monitor, we will see exactly the same output as from the simulator. At the moment, I don't have any LEDs or push buttons connected to this Mega. So let's just quickly enable the random code. And we'll do a button press for about half of the iterations. So we upload again. We begin at floor 0, go to floor 1. We get a call to floor 19, we get a call to floor about 15, 10, 8, 2, but in all cases, the elevator does not reverse direction until it reaches the uppermost call or the lowermost call and goes back to the idle state. So we go 17, 18, 19, 20, and then reverse. 16, 15, 14, clear floor 14, continue down to floor 10-ish. There's been a call back to 14 or so, but it continues going down until it reaches floor 2, floor 1, and then continues back up towards the other calls. On forever. I hope this was interesting and helps. This is the end of the official assignment 5. This is everything that is required. There are probably 2 more videos to come, which are somewhat optional, but take this to the next level with actual physical hardware being controlled by this program and by a PID algorithm that we're going to do from scratch.